Welcome back, everybody. Today we're going to be deriving the quadratic formula, and in the previous video I talked about completing the square and what it means geometrically and how it relates to algebra. And today we're going to be using that concept of completing the square to solve for the quadratic equation. So when we have a quadratic formula, or when we have the quadratic equation, so ax squared plus bx plus c, and we set that to equal to 0. So when we're using, the purpose of the quadratic equation is actually to find the roots of a quadratic equation. So what we're going to say is that this right here, we're trying to find the roots, or when the equation itself equals 0. So that is our goal when solving for the quadratic formula. So the main technique for solving for the quadratic formula is actually to complete the square. So the first thing I'm going to do is divide by a on all the variables. So this is going to be b over ax plus c over a, and that's going to equal 0. So now what we're going to do is actually complete the square. So to do that, all we have to do is take this quantity, so x plus, we're going to take the coefficient of x and divide it by 2. So we're going to add that right here. And we're going to take this quantity squared and then plus c over a. And then we have to add that extra bit, or that little piece of the square, when we complete the square. And if you don't understand what I'm saying, please watch my video about completing the square. And we have to add that little extra area to this side of the equation to make everything balanced. So this is going to be 4a squared. So we're just going to, we halved the coefficient of x, and then we squared it and moved it on this side of the equation so that we could have this balance of the equation. So what I'm saying is that these two equations are still equal. So our goal of this problem is to find x. So all we have to do is subtract c over a on both sides. So what we get is x plus b over 2a squared equals b squared minus 4a squared minus c over a. So the next thing I'm going to do is actually find a common denominator of this so we can actually collect these terms. So I'm going to multiply the numerator and denominator of c over a by 4a. And if we do that, what we get is b squared minus 4ac divided by 4a squared. And that's going to equal x plus b over 2a quantity squared. So the next thing I'm going to do is actually take the square root of this, of both sides of the equation. So we're going to get x plus b over 2a, and that's going to equal plus or minus the square root of b squared minus 4ac. And then the square root of the denominator is simply going to be 2 over a, or 2 times a. And the reason why this is a plus or minus is because we have a even number for the exponent. So when we do the nth root, so to speak, of an even root, we're going to have to use this plus or minus sign, meaning there's a chance that there's going to be two values for this square root. To put it more in a practical sense, so we could say that the square root of 9 is equal to 3 times 3. But it also equals negative 3 times negative 3. So there is a positive value as well as a negative value. So that's what this plus or minus is saying for this problem. So all we have to do is actually isolate x. So from here, all we have to say is that x equals negative b over 2a plus or minus the square root of b squared minus 4ac divided by 2a. And since these are already the same denominators on both terms, we can collect these like terms together so we get one nice quotient. So we could say that x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. And this is the quadratic formula. So we're technically done with the derivation, but we should explore this equation a little bit further and see what it actually gives us. So these two values right here, this negative b and this 2a, are not very special. They're just constants or some number that is dependent on the quadratic equation that we solved that was set equal to 0. What's special about this equation is the square root part of the equation. And that's simply because this value can be inconclusive or not real, because if there's a negative value within the square root, it transcends the real domain, the real number domain, into the complex domain, or the imaginary numbers. What can happen is that if b squared minus 4ac is negative or less than 0, what that means is that the quadratic equation that we're looking for doesn't have any real roots. So what that means is that it never touches the x-axis. So it could look something like this, or it could look something like this. This is the idea of the discriminant. If the discriminant itself is negative, therefore it will have the quadratic equation will not have any real roots. It will have complex roots, but in the terms of the graph that we see, there are no real roots, or the quadratic equation never touches the x-axis. So if we say that b squared minus 4ac is greater than 0, what that implies is that there exactly exist two different real roots. So the equation will look something like this. And the reason why I know there's going to be two real roots instead of just one is because of this plus or minus sign. Plus or minus sign signifies that there's two values accompanying this equation if this value, or the discriminant, b squared minus 4ac, is greater than 0. So this plus or minus sign signifies two different values, therefore there must exist two real roots for the quadratic equation. And there's one last case for the discriminant, and that's going to be b squared minus 4ac actually equaling 0. And what that means is that if this discriminant equals 0, the square root of 0 is just 0. And what that means when you add or subtract 0, that's just, not even there. So really we just have an equation that is dependent on negative b over 2a. So since there's only one value coming out from the quadratic equation, there is only one real root. And what that means in terms of the graph is that the equation only touches the x-axis one time. So you could think of this as x squared, y equals x squared or something. It could also look something like this as well. It could just be, pointing concave downward, and you have only one real point. So again, if the value is negative, the discriminant is negative, there are no real roots. If the discriminant is positive, then there's exactly two real roots, as shown right here, which means it touches, or the quadratic equation touches the x-axis two times. Now, if the discriminant equals exactly 0, that means the quadratic equation only touches the x-axis once, and that is shown right here. So hopefully that helped you with understanding what the quadratic formula is and how it's derived using the idea of completing the square. If you don't understand the idea of completing the square, please check my other video. It will definitely help you understand this derivation. So with that being said, I'll see you in the next video.